Hello, Mr. Burrell here. We're in the middle of Unit 10. We've talked about degrees and radians as different ways to measure angles. We've talked about drawing angles. We've talked about coterminal angles. Now we're going to talk about quadrants and reference angles. A lot about angles. You'll notice that this first unit that we talk about trigonometry a little bit, we talk a lot about angles and a lot of review of previous trigonometry, because it's going to help us a lot in the upcoming units. Where having this as kind of a foundation is going to be really, really helpful and make everything else we do a lot easier. So quadrants and reference angles. This lesson, by the end of this lesson, by the end of this video, I hope that you will know the names of the different quadrants. This shouldn't be terribly new information, but I'll remind you. Identify in which quadrant the terminal side of an angle is located. Remember, terminal side is that side where the angle ends, right here. And identify and find reference angles. So that's going to be the big thing that we're going to talk about in this lesson that I want you to get. In the past, you've probably been exposed to this before, but the coordinate grid is split into quadrants in order to make it easier to locate angles. The quadrants are named in the order that a positive angle passes through them. Or in other words, going clockwise, starting from x equals 0 over here, starting from this initial side. If I'm going clockwise, the quadrants are listed in that order. So this is quadrant 1, quadrant 2, quadrant 3, quadrant 4 here. So that's pretty straightforward. That's not terribly new information. Right here it says they do not change if the angle is negative. For example, if I did negative 235 degrees, that would be negative 90, negative 180, negative 235. It would still be over here in quadrant 2. So the quadrants is just a way to identify where on the coordinate grid is my terminal side going to be located. Quadrant 1, 2, 3, 4, going counterclockwise here. Okay. So let me move this down a little bit so you can see the bottom of this picture. So reference angles. We're going to now talk about reference angles. The reference angle is the angle between the terminal side of an angle and the x-axis. So let me explain. Say I have this angle right here. This is my terminal side, this angle right here. The angle, if I were to draw like a triangle between this side and the x-axis, this angle right here between the x-axis and this terminal side would be the reference angle. In this case, it's the same as the angle from this terminal side here. Over here, here's my terminal side here. So if I were to draw a triangle, a line straight down from this side down to the x-axis, this angle right here, this little red arrow here, this angle would be my reference angle, or the angle from this terminal side directly down to the x-axis. So down here, if I had an angle that went all the way around down here into the third quadrant, and I drew a line up from this terminal side to the x-axis, that angle right here from the terminal side up to the x-axis would be my reference angle. And then right here, if I went all the way over into the fourth quadrant and I drew a line here up to the x-axis, this angle right here would be my reference angle. So because as I enter a new quadrant, so in this quadrant, I'm going to have like this triangle right here where the angle is down to the x-axis. This quadrant, the angle's right here, 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 etc., etc. A reference angle will always be between 0 and 90 degrees. So let me draw you a little visual here. So say I have an angle on this side, an angle on this side, an angle on this side, an angle on this side. These angles right here are going to be my reference angles. I never go up to the y-axis. No, no, no. I always draw my reference angles from the terminal sides down to the x-axis. Kind of makes this little bow tie guy with smiley face kind of smiling at you. See that? Got a little eyebrow. Got some crazy hair. Okay, anyways, so that's what a reference angle is. We draw our angle and identify where the terminal side is, and then the reference angle is the angle between that reference between that terminal side and the x-axis. So this little bow tie can kind of be helpful to remember where those angles are located. They're always right here to the x-axis. Okay, so some general rules when identifying reference angles. If I have angles measured in radians, again, what I usually do is change the angle to degrees and then identify the reference angle and convert it back into radians. For angles that are greater than 360 degrees, like we talked about in the last lesson, in the last video, you'll find a coterminal angle between 0 and 360 degrees, and then find the reference angle. For angles that are negative, again, you find a coterminal angle between 0 and 360 degrees, and find what the reference angle would be. Okay, so let's practice identifying reference angles. So it says find the reference angle for each of the following. So first, I'm just going to sketch this angle using its initial and terminal side. So here's my initial side. I'm going to start here. I'm going to go up to 90 degrees, and then I'm going to go over to 135. That's going to be right here-ish. So that's my angle, my 135 degree angle, but I want to find the reference angle. Or in other words, I want to find the angle, if I were to draw a little line right here, here's my invisible bow tie, right? I want to find the angle between that terminal side and the x-axis. So I want to find this angle right here. Well, what is that angle? How am I supposed to find that? Well, if the angle from here is to 135 degrees, and all the way over to here would be 180 degrees, how much farther do I need to go? How much farther do I need to go if I'm at 135 degrees and I need to get to 180 degrees? Well, 180 minus 135 is 45 degrees. So 135 plus this little angle of 45 degrees would get me down to the x-axis, or down to 180 degrees. So my reference angle is this one right here, 45 degrees. If I ask you to sketch it right here, the angle would be 45 degrees. If I just asked you for what the angle would be up here, the reference angle would be 45 degrees. You'll notice that whenever I write a reference angle, again, earlier I mentioned that the reference angle is always going to be between 0 and 90 degrees, and it will always be positive, because I'm just measuring a distance. As if I took this little triangle completely off of the grid and we're trying to find this angle, it wouldn't make any sense if I had like a negative 45 degrees in a triangle like that. It doesn't make any sense because we're just measuring a distance. So that's why our angles here are always going to be between 0 and 90, and they're going to be positive. Okay, let's do another one. 375 degrees. Well, 375 is more than 360, so I'm going to find a coterminal angle with 375 degrees that's between 0 and 360. So 375 minus 360 is 15 degrees. So that's going to be like right here-ish, 15 degrees. So the coterminal angle there is 375 degrees. Now, what is the angle between this terminal side and the x-axis, or this angle right here? Well, in this case, since 15 degrees is in the first quadrant, that 15 degrees is the reference angle. In this case, the actual coterminal angle, 15 degrees, is also the reference angle. So the reference angle is 15 degrees. 15 degrees. The angle between this terminal side and the x-axis going down here is 15 degrees. Okay, pretty straightforward. Let's do some radian angle measures. So here I have 4 pi thirds. So let's start by converting that into degrees. So 180 over pi. You can do this without converting it to degrees, but especially starting out with these, I think it's easier to convert it into degrees because that's more where our brain works. So 4 pi thirds times 180 over pi, that's our conversion to convert this into degrees. So my pi's cancel out. 180 times 4 thirds is 240 degrees. Okay. That's between 0 and 360, so let's draw this on my grid. So here's 90, 180, and then I have to go 180, add 60 more degrees, so I'm going to be like right here. That's my angle of 240 degrees. Okay, there's my angle. Now, what's my reference angle? I need to find out what the angle between this terminal side and the x-axis is. I'm going to tell you right now, we're really tempted because it's so close right here to want to find this angle right here. But no, if you remember my little bow tie, I have to find these angles right here because that would make little eyeballs there. So I'm going to have to find this angle right here. So the angle between 180 degrees here up to 240. So how much of an angle do I need to take to get from 180 up to 240? Well, 240 minus 180 is 60. So my reference angle here is 60 degrees. So my final answer? Well, it would be if I was given an angle that was in degrees, but I'm given an angle that's in radians. So I need to convert 60 degrees back to radians. 60 degrees times pi divided by 180, that's my conversion. So 60 divided by 180 written as a fraction is 1/3 pi, or pi over 3. So my reference angle, the reference angle for 4 pi thirds is equal to pi thirds. My reference angle, or the angle between the terminal side and the x-axis, is pi thirds. Okay. Let's move on to this one right here. I have negative pi halves. I'm going to start by converting that to an angle, a degree measurement by multiplying by 180 over pi. 180 divided by 2, that's going to give me negative 90. Negative 90 degrees. So let's see here. That's not between 0 and 360, so let's take negative 90 plus 360. I'm going to get plus 360, I'm going to get 270. So 270 degrees. Let's draw that angle. I'm going to start here, go 90, 180, 270. I have an interesting situation here. I have an angle all the way up to 270 degrees. So my reference angle is the angle written between this terminal side and the shortest distance to the x-axis. Well, because I'm directly perpendicular to the x-axis, I could draw a terminal angle either this way or this way. Right? The angle between this side and the x-axis in either direction is going to be a right angle, or 90 degrees. So my reference angle is 90 degrees. That's the angle between this terminal side and the x-axis. So 90 degrees converted back into radians. If I multiply that by pi divided by 180, when I simplify that, I get pi halves. So my reference angle is pi halves. Notice it's really similar to what I started with. I had a negative pi halves. My reference angle is pi halves. It's just the positive angle distance between the terminal side and the x-axis. So pi halves, or 90 degrees. Okay, let's do a couple of the homework problems. This is number 13 and number 18 off of your homework. So here I have 165 degrees. That's between 0 and 360. So let's just draw this. So let's see, here's 90 degrees, and I need to go 75 more degrees, right? I don't know, right here-ish. That's 165 degrees. So I need to find the reference angle, or I need to find the angle between that terminal side and the x-axis. If I were to draw my little bow tie here, I need to find the angle between that terminal side and the x-axis. Well, the x-axis is, if I go all the way to the x-axis, that's 180 degrees. So what's the distance here in an angle measure between 165 degrees and 180 degrees? Well, 180 minus 165 is 15. So my reference angle is 15 degrees. And that's it. That's my reference angle, 15 degrees. That's number 13 on your homework. Number 18, I have 5 pi thirds. So again, you can do this leaving it in radians. It's easier to kind of start off with, again, to do it in degrees. So I'm going to go ahead and convert this into degrees. Convert it using 180 divided by pi. So 5 pi thirds times 180 over pi. The pi's cancel. I have 180 times 5 thirds, which is 300 degrees. So let's draw my angle. I have 90, 180, 270. I need to go a little bit farther to reach 300 degrees. That's 300 degrees. So that's my angle. In order to find the reference angle, I need to find the angle between this terminal side and the x-axis. So this angle right here. If I was going from 300 degrees all the way back to this original x-axis, that's from 300 all the way to 360 degrees. So my reference angle is going to be the distance between 300 and 360 degrees, or 60 degrees. My reference angle is 60 degrees. Okay, well, my angle was given to me in radians, so I need to convert this angle measure back to radians. So 60 degrees times pi divided by 180. When I simplify that fraction, 60 divided by 180 is 1/3 pi, or pi thirds. So my reference angle is pi thirds. Notice how my original angle is 5 pi thirds. See if you notice anything while you're doing your homework when you're converting radian measures, how the radian measure compares to the reference angle as a radian measure. Pay attention to the denominators here and see what you notice. I want you to tell me what you notice. I think those are pretty cool relationships. So Mr. Brill, why are we talking about reference angles? Why does this even matter? Why don't we just stick with the angles between 0 and 360 degrees? Well, in the upcoming units, when we start working more with angles, when we start working more into trigonometry, when we're talking about sine, cosine, and tangent, it's going to be really helpful and really important to be able to identify angles by their reference angles between 0 and 90 degrees, or between 0 and pi halves. It's going to be extremely helpful to be able to calculate sine, cosine, and tangent values and other trigonometric functions when the angles are more easy to work with, more specifically when they're in this reference range. So that's why we're talking about this. That's why we want to be able to get pretty good at identifying these. Let's do just one or two more. Negative 490 degrees. That's not between 0 and 360. And again, if you're feeling good, you don't need to finish watching this video if you don't want these extra homework examples, but they might be helpful. So negative 490, I need to convert to a value between 0 and 360. So when I add 360 twice, I get 230 degrees. Well, 230 degrees, this is 90, 180, so I need to go like 50 more, so I need to go like right there to get 230 degrees. Well, my reference angle is going to be this one right here, the measure of the angle between the terminal side and the x-axis. Well, to get from 180 up to 230 degrees, that reference angle is 50 degrees. So the reference angle is 50 degrees. How about the angle measure 23 pi sixths? Well, let's convert this to degrees. 180, I'm going to multiply by 180 divided by pi. So when I take 180 times 23 sixths, I get 690. Well, that's for sure not between 0 and 360. So 690 minus 360 is 330. Okay, well, here's 90, 180, 270, and I need to go like 60 more degrees. I need to go to like right there. That's 330 degrees. Well, to get from, again, now I'm finding the reference angle, and you find the angle between that terminal side and the x-axis. So the angle between The terminal side in the x-axis here is the distance from 330 degrees all the way back to 360 degrees. So that reference angle is 30 degrees. That reference angle is 30 degrees. But my question was in radians, so I need to convert that back into radians by multiplying by pi divided by 180. So 30 divided by 180, if I write that as a fraction, is 1/6, or my reference angle is pi over 6. Notice again, my original angle measure was 23 pi over 6. My reference angle is pi over 6. Coincidence? You decide. As you're going through your homework, let me know if that's a coincidence. Okay, that's what I wanted you to do. Pretty straightforward. I want you to know the names of the different quadrants. So on the homework, I think I asked you, after you identify the reference angle, to determine which quadrant it's in, 1, 2, 3, or 4. I want you to be able to identify and find those reference angles. That's the big piece. Those reference angles that are between 0 and 90 degrees, or between 0 and pi halves. So I hope that was helpful. I hope that was a lot of fun. I know I had a lot of fun making it, and I hope that you enjoyed that as much as I did.